how did humans get here, and where are we going? In this series, we'll explore the origin of humanity. We'll dive deep into each step of the evolution of our ancestors, and we'll speculate about a possible future for our species. By the end of the series, you'll have a reinvigorated perspective, a renewed sense of hope in being human. To begin our journey, we start at a little rock called the Earth. This is where life began, as far as we know it. Before 4.1 billion years ago, there was no life on the Earth, but all the building blocks of life were there. They were created by chemistry on the Earth itself. By 4.1 billion years ago, there was a witch's brew of chemistry on the Earth's oceans and surface, which facilitated the production of the first protocells. Through chemical evolution, these first protocells contained complex organic molecules that were able to perform some early versions of replication. The intricate molecular arrangement of these early cells were almost completely preserved through each replication process. However, each successive iteration developed very slight variations. Some of these variations aided their survival. All the variations didn't. And so the succeeding generations of these organisms continued all the way from 4.1 billion years ago to today. Life is like an ever-growing tree that never stops branching, just branches upon branches. We humans and all the other living organisms are at the outermost branches of the tree. But if you trace each branch back, you find that they all share a common stump. That's how life works. All organisms living today are related in some way. We all share a branch on the same tree of life. The more tightly connected the branches of the tree are on the tree of life, the more closely related they are to each other genetically. And so throughout this series, we're going to go from the beginning of the tree of life and trace all the branches up until we reach our human branch on the tree of life. And so our very first ancestors were those single-celled organisms we were talking about before, those ones that emerged from chemical evolution 4.1 billion years ago. From then until about 800 million years ago, life became multicellular, and sponge-like organisms emerged. Those were also our ancestors. 600 million years ago, the first animals evolved in the oceans. These are worm-like and jelly-like animals. And our closest branch, the path to humans, were these worm-like bilateral organisms. By 500 million years ago, the tree of life split into some of the first fish, and so our closest ancestors were the Hycoichthys fish in the oceans. These early fish were jawless, but they had some vision capabilities and touch capabilities, and so some scientists believe this is when consciousness first began to emerge in animals. By 350 million years ago, fish-like amphibians made their way with limited abilities on land. These closest ancestors called Tiktaalik. 320 million years ago, the amphibious branch split into two more branches, the synapsids and the sauropsids. The sauropsids became the dinosaurs. The synapsids, not quite reptiles, but looked very much like reptiles, were our ancestors. One of them called Archaeopteryx. 250 million years ago was when our branch evolved into mammals for the first time. One of them was the Thernaxodon, one of the closest things to mammals there were at the time. 160 million years ago, these mammalian ancestors, they got smaller because of the competition from the dinosaurs. And so, like the Morganocodon, for example, was a small shrew-like mammal, our closest ancestor at this time. By 70 million years ago, one of the branches of these small mammals became the Purgatorius, our closest ancestor that survived the dinosaur impact about 66 million years ago. And so this guy right here is the earliest example that science knows of a primate or a proto-primate. This was our ancestor that survived the dinosaur apocalypse. This guy had specialized molars for consuming fruits and seeds, and it could climb trees and navigate through the branches. This is the moment that marked the beginning of our tree-dwelling lives as primates. This little guy didn't know it, but he was the beginning of what we would all become today and in the future. Stay tuned for the next in the series. Our first primate ancestor that ever lived in North America, specifically Montana, 65 million years ago. That's right, primates came from America. Back then, the world was much warmer back then. There were no ice caps, and even in the Arctic, there were tropical trees. Purgatorius ancestors, they loved and thrived in the trees, eating fruits and nuts and seeds. Now that the dinosaurs were all gone, they could fill their own niches in trees and in the jungles. Trees that flowered and gave out fruits were fairly new to the scene, and so these Purgatorius ancestors took advantage of this new food source that gave them lots of energy. But by 55 million years ago, there was some competition brewing in the trees. Archicebus, our closest ancestor at the time, became a specialist in trees. It traded its clawed hands for fingernails that can pick and pry at fruit better. Their hands also became more touch sensitive, allowing their hands to become these very precise tools at manipulating objects and food and others in their environment. And by this time, 55 million years ago, our ancestors had already migrated to China from North America, because back then Alaska was connected to Asia. By 40 million years ago, our ancestor Catapithecus, they became masters at high-speed leaping from branch to branch and tree to tree. This is when their eyes became fully front-facing instead of on the sides for better stereoscopic vision and depth perception as they were jumping from branch to branch. This also required more brain power, and hence bigger brains fueled by things like fruits and seeds and nuts and some insects. It's important to note that these animals didn't just evolve for the sake of evolving. No, it was natural selection. It was the ones who had this better stereoscopic vision that allowed them to survive better, hence they would spread their genes more, versus the ones who didn't have that kind of vision, they died off. So that's how kind of natural selection works. It's not like Power Rangers where you decide to change and morph into something because you want to. It's nature selecting, not the animal itself. Now, 30 million years ago was a major turning point in the evolution of our ancestors, as Egyptopithecus, and you can guess by the name, these guys lived in Egypt. They migrated across Eurasia into Egypt, but by this time, the earth had cooled, such that trees and jungles and forests became more sparse. Trees became more farther spread apart from each other. Food became harder and harder to find. In order to survive, our ancestors had to expand further outward into the world. They couldn't just sit in their beloved treetops. See, ever since Purgatorius, our ancestors were nocturnal. They went hunting during the night, not during the day, because that's when the least amount of predators were out at night, right? And so they actually slept during the day, under logs, underground. Over time, our ancestors had to move more and more during the day with more exposure to predators. This was the big switch from nocturnal to diurnal, more day active. To survive, they developed more trichromatic vision. They can see colorful fruits from trees from afar. And to further protect them from predators, they started living in larger and larger groups together. And this caused a feedback loop of intelligence in these ancestors as they had to learn spatial memory, where which trees were with the fruits that were ripe at certain times of the year, which forest to go to, where the predators were, where they weren't. Scientists also believe in the many eyes hypothesis, where you would have one animal consume fruit while the other animals around them in their group watch for predators. And they would do this for everyone to make sure everybody got food and then go back to the trees. They even developed some vocalizations to warn the group of a predator. And of course, this is when their social capabilities really evolved, as grooming became more prevalent in these groups and they developed more familial connections with one another. All of it was their key to survival in these ancient jungles and forests, where you had hawks and snakes and crocodiles and cats and lions trying to consume them at any chance they could during the day. And by 20 million years ago, Proconsul, our first ape ancestor in Africa. By this time, Proconsul became fairly large. It was like almost the size of modern-day chimpanzees, about 50 kilograms. And so they were too heavy to walk on top of branches anymore. They had instead swing with their arms, grasping the branches, and stepping on branches below them to distribute their weight properly. And so instead of stiff shoulders like dogs where they can't really move their arm that much, Proconsul developed rotating shoulders where it can move its arms 360 degrees so that it can reach in all directions for fruits, for objects, for anything. They also lost their tails because monkeys use their tails to counterbalance their weight when they're running on branches. But Proconsul didn't do that. In fact, having a tail would actually be worse for them, because predators can come bite at the tail, things like that. But they're no longer running from small branch to small branch. They're now hanging and swinging from branch to branch and moving branches towards them to hang on to as they eat their leaves and fruits in the trees. And now our ancestors are truly apes. Stay tuned for the next episode. Humanity's first ape ancestor lived 15 million years ago. It was tailless, it walked on all fours, it had rotating shoulders, allowing it to swing and hang from branches where it spent most of its time, the trees of Africa, eating fruits and leaves. But something significant happened 12 million years ago that shifted the trajectory of our ancestors forever. The Earth warmed up, and a land bridge between Europe and Africa opened up, allowing some of our ancestors to migrate into Europe, with the Gyrapithecus about 12 million years ago emerging in modern-day Greece and Turkey, where lush forests bearing sweet, energy-rich fruits became abundant. And nobody else was eating those fruits, but Gyrapithecus filled that niche. However, unlike most African fruit trees where the fruits grow right out of the trunk or right out of the major branches close to the trunk, European fruit trees had the fruits that were nice and sweet and juicy at the very tips of the branches. Gyrapithecus had to evolve over time longer arms to reach those different spots on these trees. Gyrapithecus' spines also became shorter and stiffer over time, better fit for hanging and swinging on tree branches. And so from 12 million years ago to about 9 million years ago, Europe was a fruit paradise for our ape ancestors. However, 8 million years ago, the Earth cooled down again, and fruit became more scarce and harder to find during the winter months in Europe. In order to survive, Ornithopithecus, the next iteration of our ape ancestor, had to consume nuts and tougher foods like roots, and so they developed stronger tooth enamel and stronger jaws. Over time, some Ornithopithecus populations migrated back down to Africa, the western part of it. The other populations of Ornithopithecus traveled back down to eastern Africa. By the time these guys arrived in Eastern Africa, they were way better equipped to survive the challenges that would have came after this. They had stronger teeth, stronger jaws, stronger spines, longer arms, bigger brains, and ready to face Africa. This is when the major split happened between our chimp ancestors and our human ancestors. This was the divergence. The Western populations in Africa, they went on to become modern-day chimpanzees. The Eastern populations became humans. See, all this time, the African Rift Valley had been unzipping, and by 7 million years ago, mountains were forming so high that rainwater could no longer get past the mountains, and it became so dry in the eastern part of Africa. See, on the western side of Africa, where some of our ancestors went, it was rainy, it was jungly, and there were lots of trees and fruits for our ancestors to survive comfortably. But on the eastern side, it was becoming drier and drier, harder for our ancestors to survive. But it turns out that that evolutionary pressure of needing to survive in the dry environment was the exact thing that made us human. 7 million years ago, Sahelanthropus was the first lineage of apes to diverge from the other ancestors, and they migrated across Africa into Chad. In 2001, scientists discovered the first of their fossils in Chad in Central Africa, and it suggests that they were bipedal, the first of our ancestors to be bipedal. But this was just the beginning of walking for these species, right? They were more like waddlers instead of walkers like we are today. Now, back then, the Chad area was not deserted like it is today. It was full of lush forests, but they were getting more sparse. Trees are further away, fruits are further away, and so our ancestors had to walk further and further. And walking on all fours exposes your back to the sun, and it gets hot, right? And so walking upright actually is way more efficient for heat radiation. Also, tall grasses were prevalent in Central Africa during this time, and so our ancestors walking upright had the advantage of being able to see further, looking at predators from further away. Also, walking upright allows your arms to be free, so you can carry things, you can use them for other things while you're walking. Central Africa 7 million years ago was also littered with giant lakes, and so our ancestors likely thrived around the lakes, consuming roots in the ground, eating some aquatic plants in the lakes, even consuming turtle eggs and shellfish. So our ancestors became opportunistic. However, they still were tree dwellers. They didn't walk upright all the time. In fact, it was like maybe 20% of the time they were walking upright. It wasn't until 6 million years ago with the species Auroran, where we discover that they have certain thigh bones which are really good for walking, very distinct from the femurs of chimpanzees. However, their fingers and arms were still curved in a way that suggests they were still tree dwellers for the most part. Maybe 70% of the time they were in the trees, sleeping there for sure, but 30% of the time they were walking. It turns out, per distance, it takes 4 times less energy to walk on 2 than to crawl on all 4s. So while our chimp ancestors, the one that became modern day chimpanzees, they were safe and comfortable in the western jungles of Africa, whereas the human lineage of our ape ancestors, they were not very comfortable. They were forced to survive in a way that made us human. Stay tuned for the next episode where we talk about some of the most important events in our human evolution. Our great ape ancestors 5.5 million years ago found themselves caught in the middle of chaos. As the African Rift Valley was surging upward, moisture was being blocked from the west and from the east, and so it became exceedingly dry, turning rich jungles into pulsing landscapes of sparse trees and isolated lakes. Lakes would fill up and then dry up again within a few centuries, and then pop up again somewhere else, dozens of miles away. So our ancestors had no choice but to walk their way to survival in an unstable climate, chasing the receding water and shifting food sources. But 4.4 million years ago, Ardipithecus ramidus appears in the fossil record. Its pelvic bone is broader and shorter than its predecessors. This enabled better walking. Their hair gradually thinned around their body and their sweat glands increased. This enabled better cooling and thermal regulation, walking under the hot African sun. Walking for dozens of miles at a time, they began to live in larger social groups together while they walked. This helped to protect themselves against predators as they kept many eyes on what was going on around them. Using their voices within the groups to alert others of predators and to coordinate safety also enabled social singing. Once they began walking for longer intervals at a time, they didn't have as much time to physically groom each other. Instead, they used their voices to sing to each other. Although they didn't have grammar or language, they used their voices to soothe others in their group and allow for social cohesion. 3.6 million years ago, Australopithecus afarensis. This is Lucy. In 1976, found preserved in ancient volcanic ash were the imprints of Lucy's footprints. This was the first confirmation that Lucy was fully bipedal and that she lost her graspable toe, like her predecessors had. In modern humans, your big toe tremendously helps you leap forward as you're walking. If it's too much to the side, you lose efficiency while you're walking. But Lucy had a very aligned and straight big toe, just as we do. Lucy also developed an arched foot, better for springing forward as you're walking. These guys became such efficient walkers, they were walking for 75% of their active time during the day. By this time, Lucy's brain was also about 20% larger than that of a chimpanzee's today, so their birth canals had to be larger to accommodate the larger head sizes of their offspring. Their hip bones and pelvic bones were better configured for walking during pregnancy. Scientists also noticed that Lucy's canines are far smaller than their predecessors. In modern-day chimpanzees, their canines are fairly large. Usually they use them to fend off other males as they're pursuing females. But Australopithecus's smaller canines suggest that they weren't fighting for females very often. Instead, they were more cooperative together. The females likely began choosing the more friendlier and helpful males versus the aggressive ones, because the friendlier ones could provide food and resources to their offspring. And so our ancestors became more monogamous as it was key for their survival. This also strengthened the family unit. Especially as babies' brains became bigger and bigger, the females had to give birth sooner and sooner, which means the child had to develop more out of the womb than inside the womb. See, like modern-day chimps, they are born very much more sophisticated than human babies. And so having a more secure family unit with parents and grandparents who can help the child thrive and grow was definitely key for their survival during this time. By 2.5 million years ago, Australopithecus gari evolves. As savannas expand in eastern Africa, this species finds themselves closer to herbivores and predators. Found near their fossils are bones with cut marks on them from stones. This species might be the very first one to discover how to use stone tools to butcher a carcass. These weren't hunters yet. They didn't have the sophistication yet to hunt. They were scavengers. These guys may have sat and waited for a lion to attack their prey And then once the lion's all done, they go out there and they steal the bones. And they use their stones to break apart the bone. Little sharp flakes will come off, and they can use those sharp flakes to eat away the rest of the meat, and then use their hammerstone to break the bone open in half and eat away at the marrow inside. That bone marrow was extremely energy rich in fats. This is a new niche that no other predators could have even remotely touched. This was a major turning point in our evolution. For the first time, our ancestors picked up a stone and used it to reshape nature itself. By 2.5 million years ago, we were using tools. The human epic has officially arrived. Stay tuned for the next episode where we go over the first humans. The first humans evolved 2.4 million years ago in Eastern Africa, called Homo habilis. Their brains were 30% larger than Lucy's. Lucy had a brain the size of an orange. Homo habilis had a brain the size of a grapefruit. By this time, they were using stone tools and they were master scavengers. Discovered in the Olduvai Gorge in Tanzania was a toolkit created by these first humans who used different types of stones to butcher animals, to pound in roots, and to smash bones apart to get to the bone marrow. Tool use was a positive feedback loop of intelligence because it was vital for their survival, and so the ones who were intelligent enough to use tools, they survived. That was natural selection of larger brains, and with your larger brain, you can enhance your tools and make them better. But 1.9 million years ago, Homo erectus, this was a pivotal moment in human evolution, as Homo erectus was a master at walking the savannas of Africa. It was the first ancestor who looked almost identical to us today from the neck down, as they had longer legs for walking and shorter arms. They lost most of their body hair. They could sweat just like we can. They could walk for hours in the midday heat and sun. And this enabled persistence hunting. See, humans weren't the fastest. We couldn't outrun an antelope, but we could outwalk it. A group of Homo erectus would chase an antelope through the savannas of Africa for miles. They get out of breath easily. They can't run too far, especially in the midday heat and sun. It's too much for them. And so their bodies go into heat stroke and they collapse. And the Homo erectus would come by and finish it off with stones. Now, they didn't have spears and bow and arrows yet, but this was the introduction to hunting. But now it's 1.8 million years ago. We're in the middle of the Pleistocene epoch, where the earth is getting colder, grasslands are shifting, and our Homo erectus ancestors were beginning to follow herds of animals. Because they were masters of walking, they could follow herds of animals out of Africa. And so by 1.8 million years ago, many Homo erectus populations left Africa entirely into Europe and Asia. But some of the populations of Homo erectus stayed in Africa, and that's important to keep note of. So by 1.7 million years ago, we see a divergence between Homo erectus. Some populations go into Dmanisi, Georgia, where we see their remains today. Some move into East Asia. African populations of Homo erectus saw their own sets of challenges as the climate was shifting. They had to move into modern-day Morocco and Algeria, northern Africa. This is when we see evidence of them having these sophisticated hand axes. And this implies that they were more abstract thinkers, because you had to imagine and envision the axe before you make it. 1.5 million years ago, a new innovation emerges in Africa: fire. Some Homo erectus populations start learning how to use fire. First, they had to learn how to stop running away from fire, because that's a natural animal reaction, to run away when there's a fire. Lightning strikes, brush fires were very common in northern Africa. But Homo erectus started to realize after the fire there would be smoke from the roasting of animal corpses, smaller mammals and turtles that didn't quite make it. And so they began associating that smell, that smoke, with food. The second stage was them utilizing wood and sticks to carry that fire, to kind of borrow the fire from the brush fires into their home base, where they can keep and maintain the fire going. If they didn't keep the fire going, it would go out and they would have to wait months and months until another storm comes by. 1.2 million years ago, fire was being commonly used in Homo erectus populations in northern Africa. And fire meant we could more easily digest our food and extract the calories and energy from our food. We can break down the proteins in meat better. We can break down the fiber in the plants better. We can eat more food, but potatoes, tubers, things that are hard to eat raw, we could eat more calories of. It also meant we can now sleep on the ground, because typically animals run away from fire, and so you're more protected. So by this time, we're not living in trees anymore. We don't have to live in the trees for safety. We can just live anywhere where there's fire. And it also meant we can migrate to colder climates with fire. And colder climates typically had the fatter animals, the woolly rhinoceroses, the woolly mammoths, the bisons. So because cooking made everything easier to eat, our guts became smaller, our teeth became smaller, our jaws became smaller. So less energy used for digesting food meant more energy can go into growing our brains. Sitting around fires also enabled us to have more complex vocalizations. Language began to emerge as we had more time to sit around fires and storytell. As the younger parents and younger people would hunt and gather, well, you would have the grandparents watch the children and help them grow. The family unit became more and more secure. By about 1.2 million years ago, the Levant Passage becomes a superhighway of migrations of humans. Humans are coming in and out of Africa all the time, sometimes passing by sharing knowledge about fire, about tools. By 900,000 years ago, Homo erectus was all over Africa, in Europe, and Asia. So by this time, populations of Homo erectus in Africa and Europe, they understood fire, they understood how to use tool making, they were sharing knowledge. But populations in East Asia, they were quite stable in their environment, so their technology wasn't as advanced as the Western populations. Northern Africa was like the research and development center for humans at this time. It was like the place where all the more complicated challenges were happening. But 700,000 years ago was the Great Migration of Homo erectus, the ones in Africa who were the most sophisticated with tool making and tool use. They were the ones who became Homo heidelbergensis, the next species, our direct ancestors to Homo sapiens. This is when their journey begins, and where this episode ends. Stay tuned for the next one. The second wave of early humans to journey out of Africa set the stage for one of the most epic showdowns in human evolution. 700,000 years ago, clever Homo heidelbergensis, when they were making hand axes and striking stones together, they found that certain stones like flint would actually create sparks when they struck other types of iron-rich rocks. They started to realize that some sparks, when it hit dry grass or dry bark, it actually created a fire. This was the very beginning of their ability to make fire on their own. Soon after this, in Africa, where all the R&D was going on at the time, we see them making spears out of wood and stone tips that were glued on to the ends. They discovered that birch tree bark could be covered in a pit, buried, and light a fire over it, and you can actually melt the tar out of it. And that tar becomes a kind of glue. 600,000 years ago, heidelbergensis splits into three groups, making their journey out of Africa into Europe and Asia. The heidelbergensis populations that go into Europe start breeding with other humans that were previously there, the descendants of the erectus. They become the Neanderthals. The other group of heidelbergensis goes into Asia, where they start breeding with the descendants of erectus in Asia, and they become the Denisovans. The other group of heidelbergensis stays in Africa, and so they do not become Neanderthals or Denisovans. They stay heidelbergensis. And by 500,000 years ago, this new technology of stone use and fire use is spreading around Europe and Africa. The northern populations of humans in Europe, they start adapting over time to the colder climates. They become cold specialists. They depend more and more on meat, larger game. Their brains develop larger occipital lobes to process visuals while they're hunting at nighttime. But the heidelbergensis populations that stayed in Africa this whole time, they evolved a bit differently than their counterparts. They became a bit taller, leaner, better marathon runners. They evolved a larger temporal lobe for social skills and language. The African climate was a bit different than the other climates around the world, because the Sahara would green and then become deserted again over thousands of years, and so humans in Africa were constantly forced to adapt to different conditions. Some populations of humans migrate all the way down to South Africa, near the oceans, where they start adapting to coastal environments. And so by 300,000 years ago, the humans that stayed in Africa this whole time, they become the early Homo sapiens. So sapiens were beginning to rise just as Neanderthals were emerging in Europe and the Denisovans in North Asia. Some humans migrate down to the islands near Indonesia called Homo floresiensis, and they actually adapt on these islands to become smaller. They're called the hobbits. They grow to about 3.5 feet tall because on those isolated islands, caloric intake is extremely limited, and so they adapted to becoming smaller and smaller. Now, 100,000 years ago, the Levant standoff begins. Because of climate changes in Africa, sapiens were trying to make their way out past the Levantine corridor, but they didn't know that they would be met with force from the Neanderthals. The Neanderthals were like ambush predators. They would love to wait behind trees, and they understood the European-styled forests. They were masters of it. They were also way more isolated than the sapiens. Neanderthals would live in tribes of maybe 15 or 20 people, and so they weren't adapted to other tribes. They weren't very good at social skills, and they did not like strangers. So waves of sapiens would continuously try to come up past the Levant Passage, but they would be killed off by Neanderthals. It also was getting colder and colder, and glaciation cycles were occurring, so glaciers were blocking them from passing upward. The Neanderthals were dominating the sapiens, okay, because they were used to hunting big game in the colder climates. They would thrust their spears into giant animals. And so they were way more bulkier. They were willing to break their bones. In fact, they would even cannibalize some of the sapiens. However, 74,000 years ago, Mount Toba supervolcano erupts. Ash is spewed everywhere. It blocks out the sun. It gets colder. The entire Earth cools down. This damages the Neanderthal populations, the Denisovans, and the sapiens. In fact, it's estimated that only about 10,000 individual Homo sapiens were remaining. That's only a few thousand breeding pairs of people that were left on this planet. We know this because when we study our genetics today, we find very low variations of hemoglobins, which signifies, yeah, there's only maybe a few thousand people existing at one point in time. Now, populations of Neanderthals at this time was around 30 to 40,000. And so they weren't going extinct by any means, but their empire had been weakened by the supervolcano. Now, back in Africa, sapiens were still thriving in certain isolated pockets where they were still adapting to the changing climates, improving their technology. Around this time, we see evidence of sapiens developing the first throwing spears and bow and arrow. And sapiens have been developing their language all this time in Africa as they lived in way larger groups, 100 or 150 people in a single tribe, and they would have trading networks across the entirety of Africa. They could use their language to communicate to other people in other tribes to exchange goods in case they were lacking stuff in one area. We see evidence of this by looking at certain stones we find near their fossils. Those stones actually came from places hundreds of miles away from where their fossils are found. And so we know that they were trading for hundreds of miles. And with their language came the ability to share rituals and stories and art. Sapiens had been accumulating so much knowledge in Africa all this time, so that by 60,000 years ago, when the final wave of Homo sapiens made their way out of Africa past the Levantine corridor, they met the Neanderthals with a whole new set of technology the Neanderthals just didn't have. And so sapiens outcompeted the Neanderthals at that time. And for the remainder of the Neanderthals left, we would absorb them in our genetic pool, interbreeding. Sapiens made their way across the entirety of Europe and Asia, and by 40,000 years ago, all the other human species went extinct. The final remaining humans were us, modern Homo sapiens. The environmental pressures in Africa, in that African engine room, was the reason why we were able to outcompete all the others. The knowledge and skills that we've accumulated during the hardships of survival in Africa allowed us to create fire, clothing, tools, and weaponry, in language and social skills. They all allowed us to dominate the Earth. Stay tuned for the next episode. Humans are still evolving today. We see evidence of this all throughout our bodies. In fact, we carry the ghosts of our ancestors in our DNA. The Neanderthals and Denisovans, they may be gone, but their legacies still live on in us. When Homo sapiens made the final major migration out of Africa 60,000 years ago, they began interbreeding with other Neanderthals and Denisovans in Europe and Asia. And so we absorbed a lot of their DNA in us. In fact, almost every single person outside of sub-Saharan Africa has about 1 to 4% Neanderthal DNA in them. Now, this surprises a lot of people, but Europeans don't have the most Neanderthal DNA in them. It's actually the East Asians who do, up to 9% Neanderthal DNA. The reason why is because when sapiens went up to Europe, they bred with Neanderthals, so they absorbed their DNA, but then those populations also went into East Asia, and there were some pockets of Neanderthals living in East Asia, and so they got a double dose of Neanderthal DNA. Meanwhile, the European sapiens just stayed there and never got any more Neanderthal DNA in them. Now, the Denisovans live on in the indigenous Australians the most. Up to 6% of their DNA is Denisovan, because they migrated down to these islands in Australia, where they were a bit more isolated than the other sapiens. Sapiens absorbing the Neanderthal and Denisovan DNA was crucial for their survival in these areas where they were living, in Tibet, for example. The EPAS1 gene, people in Tibet, they have that gene that allows them to survive those high altitudes. They got that from the Denisovans. Absorbing Neanderthal DNA helped sapiens fight off viruses and survive in the cold weather they never saw before. By 20,000 years ago, humans conquered almost every continent except for Antarctica. But our brains actually began to shrink about 20,000 years ago. That's right, it got smaller. But that doesn't necessarily mean we became dumber, right? What it means is that we offloaded a lot of our intelligence onto other people in our tribes. See, the Ice Age forced people to live in very tight communities where they knew everybody, right? Maybe 100, 150 people in a tribe. And so people began to rely more on others than just themselves to get things. They would just go to the spear guy to get spears, right? They would just go to the obsidian guy to get the obsidian stones. They would work together in a way that offloaded a lot of our brain power onto the collective intelligence of the community. On top of that, different tribes would talk to each other and exchange goods, exchange partners, and so people became way more reliant on others for survival than just themselves, like our hunter-gatherer ancestors before this time. And then 12,000 years ago, the climate got really stable, okay? The Holocene epoch, the climate has been stable for the past 12,000 years. Humans began settling in communities where there was lots of food. However, over time, those populations in those communities grew bigger and bigger and bigger, so they needed to get more and more food, and so the agricultural revolution begins. People realize that when you take seeds from your favorite plant and you plant it in the ground, you eventually get something from that over months. The climate was stable enough to get farming. You need predictable seasons to get farming to happen. And so that was the case about 12,000 years ago. This wasn't the case for any time before this. The last time the climate was this stable was maybe 150,000 years ago, but again, humans just were not in the position to do farming. So the Middle East, where the Levant corridor was, that's where agriculture began. And people started developing the AMY1 gene, which gave us more starch digesters in our saliva. Chimps have way less than us, but we developed more copies so that we can break down starch because we kept eating lots of potatoes and bread, stuff like that. So by 12,000 years ago, that's all people were eating. They were no longer hunting as much, they were eating mostly plants. In fact, you couldn't hunt even if you wanted to because there were too many people and not enough wild animals to hunt. And so our bodies literally adapted to eating more starchy foods like bread and potatoes. But this came with the consequences of our jaws getting smaller, our teeth getting smaller and weaker. And then about 9,000 years ago is when people started developing blue eyes. We don't quite actually know why. Perhaps it was a mix of sexual selection or people adapting to the lower light conditions in the north. But blue eyes is simply a mutation of the OCA2 gene. But even 9,000 years ago, white skin wasn't prevalent yet, even in Europe. People think that Europeans immediately became white when they settled there 40,000 years ago. No. In 2018, scientists discovered the skeleton of Cheddar Man. He lived in Britain about 9,000 years ago, and he had dark skin and blue eyes. They were able to sequence his DNA and find that he had no light skin genes, only dark skin genes that people have today. But why is this? Doesn't it make sense to have lighter skin in the north where there's less vitamin D, and that makes it easier for your skin to synthesize? Yes, but people up north during this time were still hunting, and they were still eating vitamin D-rich meat. So it tells us that agriculture didn't spread until about 8,000 years ago. And that's when it became prevalent to have white skin in Europe and in Asia. And then 5,000 years ago, cattle herding became prevalent in parts of the Middle East and in even East Africa, where people began developing certain LCT gene mutations that allow them to digest lactase up past childhood. Normally, we can't digest it past childhood. But of course, the people who were able to get this mutation survived more, and so that gene spread such that they could digest milk. And today, in 2026, we are still evolving in terms of our jaws and teeth getting smaller and smaller. In fact, that's why we see lots of people being born without wisdom teeth now. Sometimes people have wisdom teeth. They grow in all kinds of directions in your jaw because there's just not enough room anymore for them to be there. But a lot of people today are being born with less and less wisdom teeth, which means, yeah, this is active evolution happening in us right now. We're simply cooking our food and using forks and knives so much that we just don't need these big jaws and all these teeth anymore. Of course, there's an evolutionary lag in us happening today because people get anxiety, which comes from the fact that our ancestors had to be very hyper-vigilant about lions or whatever was out in the savannas, right? But we still carry that today. But now we go on our phones and we get a notification, we get that same anxiety. But our bodies are like, wait, there might be a lion there, right? But no, it's just a notification on your phone from Facebook. Or insomnia. A lot of people feel like they wake up in the morning in the middle of the night. Well, that was actually because our ancestors had to stay vigilant during the night sometimes. One person in the tribe had to stay up and watch for any predators. We are the legacy species. We carry all that evolutionary baggage going back not just to our human ancestors, but all the way back to the first cell. There's an unbroken thread that stretches from the very first cells to us. We have finally reached the end of our branch on the tree of life. But what happens next? How are we going to evolve in the future? What does the future of humanity have in store for us? Stay tuned for the final episode. How are humans going to evolve in the future? What changes are we going to see in our species and beyond? This is the finale of the Human Evolution series. Welcome to the future of humanity. In our past, nature was a brutal selector. If you had bad eyesight, or a weak immune system, or a narrow jaw, you just didn't survive to pass down your genes. But today, we have sufficient technology to fix all those problems. If you have bad eyesight, we just put on glasses. If you have a weak immune system, we just give you antibiotics. If you have wisdom teeth, we just remove them before they give you any problems. So natural selection no longer has the same pressure it once had on us. It is relaxed. In fact, we're just beginning to take control of our own evolution. Dating apps, for example, have completely changed how we mate. We're driven now by algorithms, how good you look in a photo, or how good you are at texting. Increasing amounts of people are choosing IVF now, which means that clinics can screen the embryos for any genetic diseases. Our diets have also dramatically changed in the last 100 years. We're eating way more animal products, and so we're seeing a respective increase in cardiovascular diseases, diabetes, obesity. We are now seeing the introduction of microplastics in our bloodstream and in our brains and bodies, something our species has never seen before. So all this considered, what will nature be selecting for us as a species in the future? Well, we see transportation and travel becoming way more common globally. In the past, certain phenotypical features like skin color or hair color, they may have been closed off from other regions. But in the next few thousand years, as global travel becomes way more commonplace, what will evolve is a homogeneous, mosaic phenotype. Mid-dark skin colors and darker hair, a mix of features that represent the entire planet and not just certain regions. We also might see more hyper-adaptive immune systems in people because of all the highly crowded environments we're starting to live in now. Apartment complexes, right? Urban developments. Respiratory viruses like the flu or coronaviruses, they thrive in those environments. And so in the future, humans may adapt to having immune systems that are fully immune to those viruses. The next 1,000 years, it's safe to say that we'll also have colonies in space, on Mars, on the moon. People may adapt in space to have later, longer limbs with lower bone densities, because that tends to be more efficient in space. It needs less calories to maintain. People with higher bone density tend to have more bone loss, because your body reacts to space by degrading your bones. So having thinner, later bones would actually improve efficiency for people in space. But all that might not be the only pathway that our evolution takes us. In fact, there's another path. In the past decade, we've made tremendous progress in gene editing. Right now in 2026, we can read our genetic code fairly well, but in the future, we'll be able to rewrite our genetic code entirely. Natural selection is slowing down, and soon it will stop affecting us entirely as a species. We will soon be artificially selecting ourselves. CRISPR is a technology that literally allows us to take cells out of your body, edit and repair the genetic code, and put them back into your body. In the past year, scientists have used this technology to cure sickle cell disease in some people. And scientists have just developed a method to inject the gene editor right into your bloodstream. They're using it to literally fix high cholesterol permanently in people, all with a single injection. And right now in trials, we have injections for curing things like cancer, heart disease, blindness, and lupus. Even crazier, just last week, David Sinclair has just entered phase 1 of his trial of ER100, which is a gene therapy that actually reverses aging of the eye. It reverses glaucoma. That's right, age reversal is literally within our reach. We can reverse the epigenetic clock of our bodies to slow down the aging of our cells entirely. And last year, scientists made a breakthrough in printing human heart tissue. Within 20 years, 3D printing organs may be the norm for anybody who needs a heart or a kidney or a new lung. We'll be able to take a few stem cells of your body and produce an entirely new organ that's perfectly compatible for your body. In the past year, Neuralink, a brain-computer interface, has made significant progress in people with full paralysis. They're now able to operate phones or TVs or tablets with just their thoughts. We can imagine in the future a Neuralink-like chip implanted in your brain that connects you to a digital cloud, the internet, anything, all the information in the world. Our intelligence is no longer going to be limited to the sizes of our skulls. We're going to have unlimited access to intelligence in the cloud. One day you will be able to replicate each one of your brain's thoughts and memories digitally. You'll make a digital copy of your consciousness. And so we'll no longer be confined to this one body. Perhaps in the future, you'll be able to upload your consciousness to another body, another machine organism. If we gradually replace every part of our bodies biologically with something synthetic or mechanical, will we even be humans at that point? Our successors, the next step in human evolution, may not be biological anymore. They may be machine organisms. Now, there may be some people out there who refuse to ever implement AI or robotics into their bodies. There'll be a very small isolated population of those people who remain organic, but they might not last very long, because as we know from our past, we stay comfortable for too long in one spot. It's a recipe for extinction. And so what this means is that we may be one of the last generations of legacy humans that exist. We are yet again at the brink of another divergence in the evolution of humanity. Our ancestors were wanderers. They were curious, and we still carry that torch with us today. Our descendants will carry pieces of us with them. Maybe not biologically, but mentally. The curiosity, the will to endure, the persistence to keep going. That's the spirit of humanity. No matter what happens in the future, we made our mark on the tree of life. Just as we look back and revere our hunter-gatherer ancestors that were the first wanderers, the first explorers of the land and the oceans, our descendants will look back and marvel at us, the first ones to explore the skies and space, the first civilization that, despite their fallibilities and shortcomings, found a way. I hope that after watching this series, you gained a renewed sense of hope in humanity. I see far too many people losing hope, but we cannot focus solely on our weaknesses without unifying behind our strengths. Sure, we have evolutionarily accumulated propensities for bigotry, hatred, xenophobia, but we also have propensities for love, compassion, and cooperation. We humans are capable of greatness. With all of our failures and successes comes a story of our evolution, a remarkable story of time, life, and death. As we gain an understanding of our story, let's embrace each chapter.